Hey guys, welcome to lesson 4 of unit 6. This is the last lesson for this unit. I want you to pause the video and try the do now. So the do now says expand and it's giving you this log. So when you're expanding, just count your variables. There are 3 variables, so you're going to have 3 log terms. So I'm going to do log, I'm going to write log with each one of them, a to the 4th. And remember, when it's division, it's subtraction. So log, I'll have to move back, b square. And I'm going to put this in parentheses because this was all in the denominator. Plus, there's multiplication between the two. So log cube root of c is same thing as c to the 1/3 power. Right? Now what happens to these powers? They come in the front. So I'm going to write it as 4 log a minus 2 log b. If I get rid of my parentheses, I'll have to change this plus to minus 1/3 log c. So this is how you expand it using your properties of log. So again, have your notes of log equations from lesson 3 in front of you while we do these questions. So I'm going to get started with the first one. So in the first one, and the directions say that round it to the nearest hundredth, means 2 decimal places. So remember that, okay? So the first one is you have logs on either sides. You cannot cancel. Some people will do, oh, there's one log. No, do not cancel. That will be wrong because they're on the same side. If they were on opposite side and they were one term each, then you could cancel. So what do? If you have more than one log, read in your notes, what do? You condense it. So I'm going to condense it. Log base 2. What does addition changes to? Multiplication. X plus 1 equals 5. I didn't do anything to my right side. Now it turned into just one log equation. How do you solve one log equations? By converting them into exponential form. So circle the base, run the race. So it'll be 2 to the 5th equals, I'm going to multiply these two out. Let's write it and then we'll multiply in the next step. So now 2 to the 5th is 32. And if I double distribute it, I get x squared plus x minus 3x minus 3, which would simplify to x squared minus 2x minus 3. So now it's a quadratic. How do I solve quadratics? By setting them equal to 0. So I'm going to subtract 32 on both sides, and I get x squared minus 2x minus 35 equal to 0. Now factor. There's no GCF, so I'm going to factor using my AM method. Give me two numbers that multiply to -2 and add to -2 and multiply to -35. That's what's called the AM method. It is -7, +5. Make up your T-chart and it's set each of your factors equal to 0 and solve. X equals 7, x equals -5. You are not done. Why? Because you must check both your solutions. So if I substitute 7 in here for x, do I end up with a negative number? No, it's a positive number. If I substitute 7 in here, I end up with a positive number. So 7 is a solution. But what happens if I substitute -5 in here? If I substitute -5 in here, I end up with a negative number here, which is not possible. So -5 is a reject. So you must write that down. You should cross it out and write reject. Okay? I'm going to try number 2 also. So number 2, again, you have 1 log on the left side, you have 2 on the right side. So what are you going to do? You're going to condense these two. So the left side, I'm going to rewrite it as it is. The right side, I'm going to condense it. Log base 3, and subtraction changes to division over 3x, right? I can actually simplify them. X squared over 3x is what? Just x over 3. So I'm left with log 3, 12 equals log base 3 of x over 3. Now you have logs on either side. Here you can cancel. The logs are the same base, so I have 12 equals x over 3. You're going to multiply both sides by 3 or cross multiply, whatever makes it better for you. X equals 36. Again, check. If wherever you see x, if I substitute 36, would I get a negative number? Nope. Would I get a negative number? No here. So this works. So this is a solution. So finish up the remaining packet, guys, and remember to upload this. Good luck, guys.